Welcome back to Math 103. This is video number 14 on apportionment. So earlier we applied Hamilton's method to a certain apportionment problem, and now we've applied Jefferson's method. The question is, how do they compare, and what do you notice? Well, the salient difference is that they're not the same apportionment, and in particular, Jefferson has given one extra seat to Massachusetts compared to what Hamilton gave, and that comes at the expense of Maine. Right, it's the same total number of seats, so if one seat is benefiting from Jefferson's approach, then it must be at the expense of some other state. Right? So the first observation is that it really does make a difference which apportionment method you use. This has made the issue of which apportionment method to use a very controversial one through American history. There have been very big political fights over which apportionment method should be used. Not just between Hamilton and Jefferson, but among other apportionment methods. Just as the choice of voting method can have a big impact on who actually wins the election, the choice of which apportionment method is used has consequences as well. Now, another observation is that Jefferson's apportionment favors the most populous state, okay? And therefore the one losing out is a comparatively less populous state. This is not just an accident of the current example, that is a systematic feature of Jefferson's method, that it shows some bias in favor of large states. We should not forget that Jefferson was from Virginia, and Virginia was a large state at the time. Let's summarize Jefferson's method. We guess a modified divisor slightly less than the standard divisor. We compute a modified quota for each state, in other words, state population divided by the modified divisor. We round each modified quota down to the nearest integer. That gives us the modified lower quota. We find the sum of the modified lower quotas. If that sum equals the full number of seats, then we're done. Okay, and then we've successfully found the Jefferson apportionment. If not, if the sum of modified lower quotas is less than the full number of seats, then you'll need to find a smaller modified divisor, right? If you have too few cookies, then you need a smaller cookie cutter to get the right number of cookies. If, however, the sum of modified lower quotas is greater than the full number of seats, then you need a larger modified divisor for your next attempt, right? If you have too many cookies, then you need a larger cookie cutter to get fewer cookies. Just a bit of history, Jefferson's method was in fact used from 1791 through 1842 when Webster's method was adopted, and we will study Webster's method next. It's worth noting also that Jefferson and Hamilton were political rivals, and Jefferson's method was adopted after President Washington vetoed Hamilton's method. So Hamilton's method was actually first approved by Congress, and it was vetoed in favor of Jefferson's method. For extra practice, and to set up our next example for the next point we're going to make, before going on to the next video, carry out the Jefferson apportionment for the same population, same example, but now 38 seats. If you're completely confident that you know how Jefferson's method works and you know how to do this, then you can just go directly to the next video, but if you have any doubt, then this is strongly recommended as practice. Now, it is going to be typical for purposes of this course that I will give you the following kind of a hint when I ask you to carry out Jefferson's method. Right, the hint is that one of the modified divisors on this list is going to work. Now, before trying any of them, first think whether the modified divisor should be greater than the standard divisor or less than the standard divisor.